B. Otherwise A dot B we will get. So 0 0 0 0 0 0 1 1 0 1 1 1. That is about the truth table structure is 0 0 0 1 1 0 1 1. Next one is OR gate. In OR gate again 2 inputs 1 output was there. Which operation here? Addition. So 0 0 0 0 1 1 0 1 1. Yes, very good. Then NOT gate. NOT gate, how many inputs? Only one input. So you will get a triangle shape here like PN diode only. For that you will get a bubble here. How many inputs? Only one input, and then output is what here? Complementary of that. A means A bar. 0 1. Yes. Then after that we have discussed the NAND gate. In NAND gate again how many inputs are there? 2 inputs and then 1 output. NAND gate is formed by what? AND plus NOT. AND plus NOT you have to take, and then don't confuse about the what is that truth table. You tell me proper answers. Like this finally you will get the NAND gate. One AND, another is NOT, so that we can form a NAND gate. Now for the NAND gate 0 0 1 0 1. You just assume the AND gate in your mind and then just do complementary for that. 0 0 0 1 1 0 1 1. Yes, very good. Then NOR gate. NOR gate nothing but R plus NOT. R plus NOT gives you the NOR gate. The symbol will be like this. Shivu, I called you so many times, so I am getting symbol. So this is a NOR gate. NOR gate 0 0. Yes, 0 1 1 0 1 1. Yes, very good. XOR. Not first XOR, second XOR. Remember second XOR. Yesterday we have discussed 2 XORs and then 2 XNORs actually. Yes, XOR. AB. First of all, tell me the Boolean expression for this. Very important. AB bar plus BA bar. And we have seen some circuit diagram for that, equivalent circuit diagram also. Then after that, now tell me the truth table for this. 0 0 0 1 1 0 1 1. Yes, very good. Then XNOR is exactly opposite to that, of course. And now tell me the Boolean expression for this. A bar B bar plus AB. See that in this actually you will get one complementary, one true value. So in this 2 complementaries and then 2 true values. That is how you have to remember the Boolean expressions of XOR and then XNOR. And before that we have done the additions. Addition was very easy. 1 plus 1 is how much? 1 plus 1 1 0. Addition, Boolean addition I am saying about. So 1 plus 1 is 1 0. 1 plus 1 plus 1 is how much? 1 and 1. Now 0 minus 1 is how much? 1 only you will get. Borrow will be 1. So that is about the binary addition and then binary subtraction we have discussed. And before that we have converted the binary number into the decimal, decimal number into the binary. Decimal to binary, what you have to do? Divide with 2. Always you have to divide by 2 and then you have to write the remaining 1 or 0. Then you have to write from all the number from where to where? Bottom to top, or otherwise top to bottom? Bottom to top. Then that is about the decimal to binary conversion. Then binary to decimal, how to convert that? Starting from the right, you have to go towards the left, and then what you have to write? 2 power 0, 2 power 1, 2 power 2 and so on like that. Now wherever 0 is there, that 2 power you have to cancel. You have to add remaining all the values. That is how you have to convert the binary number into the decimal number. That is what we have discussed yesterday. And now before that we have discussed De Morgan's laws also. Do you remember the De Morgan laws? What happens? Plus will become dot, dot will become plus. Always when it will come, whenever bar is there, then only it will come. So here first De Morgan law is A plus B whole bar, A bar dot B bar. Then A dot B whole bar, A bar plus B bar. Then A bar plus B bar whole bar. What will happen? A dot B. Why? Because double complementary will come. Then A into B, A bar dot B bar whole bar. Then what will get? A plus B. So these laws will be very helpful. And now next Boolean laws we will discuss. De Morgan law is one of the Boolean expression only. For the XOR and then XNOR explanation, I have done this one before only. Okay. Now basic Boolean expressions, very important for the problem solving. This will be very helpful. Boolean expressions. I will write everything first. Later on you can tell the values. You also write along with me. Write each and every case. ಏನಮ್ಮ ಫೈಟಿಂಗು ಊಟ ಮೇಡಮ್ ಏನಕ್ಕೆ ಫೈಟಿಂಗು ಏನು ರಾಧಿಕಾ ಟಿಫಿನ್ ಜಾಸ್ತಿ ತಿಂದಿರಾ ಜಾಸ್ತಿ ತಿನ್ನಬಾರ್ದು ನಮ್ಮ ಥರನೇ ತಿನ್ನಬೇಕು ಸ್ವಲ್ಪ ಇಷ್ಟೇ ತಿನ್ನಬೇಕು ಕಾಲೇಜ್ಗೆ ಒಳ್ಳೆಯದಾಗುತ್ತೆ ನೀ ಫಿನಿಶ್ಡಾ ಎಸ್ ಸೊ ಹಿಯರ್ everything is very easy. This logic gates is chikkamakkalu concept only, so everything will be very easy. So here 1 plus a will be how much? 1 plus a is how much? Ray what is 1 plus a? 1 or a? Listen, 1 second, don't feel shy. Listen here, don't be shy. Yeah, a is equals to 0. Whenever a is equals to 0, answer is how much? 1. Whenever a is equals to 1 plus 1 is again how much? 1 only. So what you are getting here? You might be taken a as 0 or a as 1 or a as any value in the sense any function it can be. So what is the answer you are getting? Only finally 1 only. So very important, this is 1 plus any function, that might be how much ever bigger it might be, that might be ab plus ab bar plus ba bar, whatever it might be. So 1 plus anything, 1 plus anything is 1 only. Clear? This is how we can prove it. If A is equals to B, A is equals to 0, then again answer is 1, A is equals to 1 also, answer is 1 only. Clear? Then next one is A plus 0. A, of course, A plus 0 is A only. As per the A value, if you are taking the A as 1, then answer is 1. If you are taking A as 0, then answer is also 0 only. So only answer is how much here? A. Listen properly. Listen each and everything. So here, if A is equals to 0, if A is equals to 0, then what I can write here? 0 plus 0. How much answer is? 0. If A is equals to 1, then what I can say in the place of A? 1 plus 0. Answer is how much? 1. I am taking 0 as A, and then we are getting 0 only. I am taking A as 1, then we are getting the 1 only. 1 means again what? A only. So that here A plus 0 is A only. Then 1 dot A. A only, right? If A is 0, what is the answer? 0. So A. Then if A is 1, answer is 1. So again A only. So the answer is here A. A into 0 is of course 0. Then if A is equals to 1, then A bar is equals to how much? Everybody know this already? 0. A double bar is equals to 1. 1. I only said the answer. So A plus A. A plus A. Each and every case you have to just substitute this only. Then only you will get the answer. A plus A. A only, right? If I take if A is equals to 0, then what is the answer? 0 plus 0. How much is there? 0. Nothing but again A only. 0 means A only. If I take A is equals to 1, then what we can get? 1 plus 1 is 1 only. Again what is this value? 1. So the answer is how much here? A only. A dot A. A only, right? 0 into 0, 0. 1 into 1, 1. So that I can take it as A only. Now A into A bar. Later on you can copy. First of all listen all of you. A into A bar. Let's check that. If A is equals to 0, here 0 dot 0 bar nothing but how much? 1. So what is the answer? 0. If A is equals to 1, then 1 dot 0. Correct? 1 bar nothing but 0. So that what will get? 0 only. So whatever you might be taking, you might be taking A as 0 or A as 1. What is the answer you are getting? Only 0. So my answer is 0 here. Then next one is A plus AB. From now onwards these are different cases. A plus AB. Think properly what you can write that. By just seeing only you can say that. A. How you are saying that as A? 0. Then you don't know B value, right? If you are taking A as 0 and then 1, if you are checking like this only, you don't know the B value. A or B na? Who is that? Parmanand Shisha? You only. You are the best Parmanand Shisha. A is the answer. A is the answer. Yes, very good. A common tagbeku. A common tagbeku. ಇಲ್ಲಿ ನೋಡ್ರಿ A into what is remaining for us? 1 plus B. 1 plus anything is how much? 1 only. So that A into 1. What is the answer now? A only. You understand, right? So I have taken A outside here. What is remaining for us? 1 plus B. Most of the people wait, they will stop nothing but they will think about the B. We don't know the B value, so how can we solve this? So here I said already 1 plus how much ever bigger function it might be. What you will get always? 1 only. So only here A into 1 plus B is 1. So the answer is how much? A only. Next one is A into A plus B. A into A plus B. A only? Let's check that. Let's check that. So I'll send the A inside first of all. So what will come? A into A plus AB. A into A is how much? A into A is A. So that A into A is A. This is one. This one is A plus AB is remaining as it is. So A plus AB value is how much? A. Clear? So that is about the A into A plus B. I send A inside first. A into A becoming as how much? A. So that only I have taken this as A. And then plus I send the A inside, so that A into B we got. Then again what I have taken nothing but here I have taken the A common 1 plus B. And 1 plus anything is how much? 1 only. So my final answer is how much? A only. Clear? Now A plus A bar B. What is the answer? A plus A bar B. See that here A into anything is there here? Nothing, right? Can I take it as A into 1? I will take this one as A into 1 plus A bar B. Clear? Now whenever I take like this, in the place of 1 what I can write? Can I write 1 plus B? In the place 1 plus anything is how much? 1 only. So I am writing it as 1 plus B. Then I am sending the A inside. So this will be how much? A plus AB plus A bar B. A plus AB plus A bar B. Now again what I will do here means I will take B common here. So what is remaining? A plus A bar is remaining. What is A plus A bar? Have you written that? A plus A bar is how much? See that A plus A bar. How much? A. You will get A only. Why? Because if A is equals to 0, then what will you get? A is equals to 0, 0 plus 1. So what will you get here? 1. If A is equals to 1, then what will you get? 1 plus 0, the answer is how much? 1 only. So you will get how much? 1 of course. So here A plus A bar is how much? 1. B plus B bar is 1 only. So this is 1. Then A plus B is the final answer for that. So this function gives you the answer of A plus B. Let's check again. I will explain again. So that A plus A bar B, this is the function we are having. For that I want to convert into some other minimal expression. For that purpose what I will do nothing but I will write in the place of A into nothing is there means 1 I can write A into 1 plus A bar into B. So that A into in the place of 1 what I can write? I can write it as 1 plus B. 1 plus anything is how much? 1 only. So then A bar into B. How do you know how to know that we have to write only 1 plus B? Why? Because I want to minimize this. Even B also there. I have already 2 functions of A here. I should get 2 functions of B also of course. So only I am just taking in the place of 1 as 1 plus B. If C is there we have to take of course 1 plus C only. Then here I am sending the A and then A inside AB plus then A bar into B. Then A plus what I can take common here? B I can take common. What is remaining? A plus A bar. So what is this A plus A bar? A plus A bar. So if A is equals to 0, then what I can write? 0 plus 0 bar means how much? 1. Then 0 plus 1 answer is 1. Then if A is equals to 1, then what I can write? 1 plus 1 bar is how much? 0. Then answer is how much? 1 only again. You might be take A as 0 or A as 1. What is the answer you are getting? Only 1. So this A plus A bar value also how much? 1 only. So this is entirely 1. Then what is the final answer here? A plus B. Clear? Then A into A bar plus B. What is the answer for this? See that? A I will send inside. Whenever I send the A inside, then what will you get here? A into A bar plus AB. A into A bar is how much? 0. So that this will become 0. So what is your answer? Only AB. Clear? So listen again. Everything listen again. 1 plus A is 1 only. Most of the people will write 1 plus A as A only. But that's wrong. 1 plus A is only 1. So 1 plus A is 1 because here if I substitute in the place of A as 0, then my answer is how much here? 1. And then if I substitute A as 1, my answer is how much here? 1 only. Every time I am getting 1 only. So my final answer also how much? 1. So 1 plus A or A plus 1 or 1 plus B or 1 plus C, whatever it might be, 1 plus this much of bigger function also becomes how much? Only 1 always. Then after that A plus 0 is of course A only, 1 into A is of course A, and then A into 0 is 0. These are easy. Then A plus A is how much? A only. If I take both are zeros, my answer is 0. If I take 1, then my answer is 1. So A plus A is A only of course. Now here only you write A plus A bar is equals to how much? A plus A bar is equals to how much we got here? 1. That is 1. Then after that A into A is A. A into A bar is how much? 0. Then A plus AB. In that what I can do? Nothing but I can take A outside. Then what is remaining? 1 plus anything is how much? 1 plus anything is 1 only, so that I have taken this as 1. Then what is remaining here? A only remaining. Then A into A plus B. A into A plus B, I am sending A inside simply. Then what will get here? A into A is A. A into B. A into B we got. A into A is A and then A into B is AB only. From that I am taking A as common. Again this function only. From now onwards we got this function only here. Clear? Again answer is how much here? A only. Next. A plus A bar B. A plus A bar B means this one is little tricky one. So in the place of 1 I am taking it as 1 plus B. After that I am minimizing in this manner. So my answer is how much we are getting? A plus B. Then next one is A into A bar plus B. A into A bar plus B is AB only. Why? Because I am sending A inside. A into A bar becomes how much? 0. Then what is remaining? Only AB is remaining. Clear? These are the basic Boolean expressions. And after that we will see the commutative law. Commutative law very easy. What is that? A plus B is equals to B plus A. Anything you have to take in the mirror image, that's it. A plus B is equals to B plus A. And then A into B is equals to how much? B into A. Then associative law. Associative law nothing but A plus B plus C is equals to A plus B plus C. Just shifting the brackets only, that's it. Then A dot B dot C is equals to what I can write? A dot B dot C. Then distributive law. Distributive law nothing but A plus B into C. I can write as what here? A plus B into A plus C. Correct? You are just sending A inside, that's it. You are just multiplying with each and every term. Then A into B plus C. What will you get? A into B plus C. A into B plus A into C. Are you sleeping? Yes? Yes. De Morgan laws. A plus B whole bar is equals to what happens? A bar dot B bar. A dot B whole bar is A bar plus B bar. A bar plus B bar whole bar is what? A dot B. A bar dot B bar whole bar is equals to A plus B. These are the De Morgan laws we already know. So everything you copy. Wake up all of you. Wake up and copy everything. Side kodbeka. This explanation is there only. Duster ekkundi? ఇంకేసుకోండప్ప యతీష్ ఇంకేసుకోండి. I have written already, okay. Finished, huh? Next, write a problem. In the figure below, In the figure below, below, two input waveforms are shown. Two input waveforms A and B are shown. Two input waveforms A and B are shown. Then name the logic gate. Write the truth table. Write truth table. Write the truth table. Next, give the output waveform. This is how the questions will be asked. Two inputs are given. First of all, tell me which gate that is. Done. This much time. Which gate? Output waveform. Waveform kotilala. Right. Now you take. Abba ಮಾಡ್ಕೊರಿ. ಹಬ್ಬನ ಹಬ್ಬ ಅಂದರೆ ಹಬ್ಬ बोले तो इधरे हब्बा बोले तो आश्चर्य एक्सप्रेशन फॉर द ಔಟ್ಪುಟ್ ವೇವ್ ಫಾರ್ಮ್ ಡ್ರಾ ಮಾಡಿರಿ ಎಲ್ಲರೂ. ಗೇಟ್ ಕೊಟ್ಟಿದ್ದೀನಿ, ನ್ಯಾಂಡ್ ಗೇಟ್. Got it? Yes, have you drawn the waveform? So first one is low na high na? First cycle is high. Next cycle low. Next high. Yes, high it is, then low, then high, then high, then yes, high. I'll draw it. NAND gate, no, I have given NAND gate. These are the two inputs of NAND gate. Of course, you have to identify the output waveform. For that output waveform, what I will do, nothing but I will just first of all write the truth table of NAND gate. Truth table of NAND gate is A and then B and then A dot B whole bar 0 0. NAND gate 0 0 1 0 1 1 1 0 1 1 1 0. Whenever you know the truth table in your mind, there is no need to write this and all, there is no need to draw anything. In that, 2 lows nothing but 1 high we will get, nothing but 2 lows 1 high, and then 2 highs 1 low will get. Wherever high is there, there only will get the low. That's it. Except all the cases, what will get here? 1 only, high only. So here 2 zeros. This is 0 of course. 0 1 0 1 0 1 0 1 0 1 they have given. Then 0 1 1 1. Okay. Yes, okay. Then output C. C is equals to, whenever 0 0 is there, what is my output here? 1. So only I have to draw 1 here, higher. Then here what is there? 1 and then 1. 1 1, what is the answer? 0. So that come down and then 0 that is. Then after that 0 1 0 1 0 1 1. So that go up again. Then after that 1 and then 1. 1 1 is 0. 1 1 is how much here? 0. So that come down again like this. Then after that next case is 0 0. 0 0 is 1. Go up. And then again how much? 1 and then 0. 1 0 is how much? 1. So that again up only. Then 0 1 1. So again up only. Then after that 1 0. 1 0 is 1 only. Then again up. We came already here I think. Next 0 0. 0 0 is 1. So again up. Then 1 and then 1 down. This is a correct output waveform. So here is here. See here again. 0 0. 0 0 is how much? NAND gate. People. Yes, are you there? Brahmanandams. 0 0 1 1 1 0 1. Idi nodi helbardu. Okay na? You remember the truth table in your mind. Then only you tell me. Then only you can verify it. I am verifying it by the way. I know this is 1, this is 0. But I am verifying it. So here 0 into 1 in the NAND gate is how much? 1. And then 1 1 is 0 0 0 1 1 0 1 0 1 1 1 0 1 0 0 1 and then 0. I know you people said by seeing that waveform only. Y is equals to LE. Yes, very good. That's the next problem. Find the Boolean expression of Y. Actually, in the problems, what they will give nothing but they will give these 3 waveforms. A and then B are inputs and then C is output, like that they will see, and then they will give the options NAND, NOR, and then NOR, like that they will give. So that you have to identify which gate that is. हासिफ जाके पानी का बॉटल लेकर जा. वो बबल नहीं रहे, मेरा बॉटल रहेगा ना तो बाहुबल है ना, बबल ही उठा लेकर आएगा. तो you got the Boolean expression for that. Solve slowly. What is the answer you got? B. A minus B. B is the answer. Only B is the answer. Yes. How many of you got that B? 1 2 3 4 5. Very good, very good. Only B is the answer for that. Only B is the answer for that. Come on, Shivu. Yaro karidru. Next problem. ಯಾವುದು ಬಿ ಎ ಬಾರ ಇಲ್ಲ ನೋಡು ಚೆನ್ನಾಗಿ ನೋಡು shall I prove this one? Now how many of you got that B? Yes, very good Nana. See, look at this, so here I have taken first of all A. This is which gate here? What I have done here? Two inputs are combined, nothing but which gate that is? NOT gate. Don't think that that is NAND. Not from the NAND we got there. So this is not here, this is not, and then this is which gate here? NOR gate, and then this is which gate? OR gate. First of all identify the gates. Then here A is there. Here what is the output here? A bar. Here how much is going? B. So that output is how much? B bar. I am giving A bar and then plus B bar. For which gate I am giving? NOR gate. So that what will get? Whole bar. Which expression this is? Do you remember any formula from this? Which is that? De Morgan law. What is the answer? A into B. So that A into B is one of the input for that gate. And then here how much is going? Only straight away B is going. So what is the answer here? AB plus B. Correct? Because which gate this is? OR gate. AB plus B nothing but what I can take common here? B I can take common. So that B I will take common. So what is remaining? A plus 1. 1 plus anything is how much? 1 only. Then what is the answer? B is the answer. That is the correct one. Clear? That is how you have to solve. Then next come to this problem. What is the answer for this? Different answers you people are saying. Listen here. Yes, let me do this. A and then B I applied here. So what is the answer you will get here? A plus B whole bar. A plus B whole bar. Here how much is going? B is going. Which gate this is? AND gate. So AND gate means I will do some more thing here. A plus B whole bar means from the De Morgan what I can take? A bar dot B bar. Whenever you take the AND gate here, what will you get here? A bar dot B bar into how much is there? B is there. So whenever you send A bar into B, and then what I can write here? Yes, B into B bar. B into B bar is how much here? B into B bar is how much? A into A bar is how much? 0. B into B bar also 0 only. So this is 0 here. Then entire answer is how much here? 0. Why you are getting different answers? You said till here only. You said me the answer till here. Yes, this is correct only. This is correct, but the final answer is how much? 0. Whatever you have done, that is correct only. But whenever you see here B into B bar is there means you have to take it as 0. Okay, you have done correct only. Very good. If you don't apply the De Morgan, then what will you get the answer? Final answer? A plus B whole bar into B, na? That's it. You will get this answer. Either this one also correct only, but two answers cannot be given in the options, so that only one answer will be given. Either 0 or this answer or this answer. Okay, 3 are correct answers only. Then next one. Next one is this one. Which gate that is? OR gate. Yesterday already we have proven this one. Yes, this came 2 times in the previous NEET. This question already we have proven yesterday only in the universal gates. NAND gate is a universal gate, in that we have proven 2 times came in the NEET. So that observe each and everything properly. This is of course here A bar is there, here of course B bar is coming. So that this one I can write as what? A bar plus B bar whole bar. So what is this? A dot B. A dot B na A plus B na? A is into la. This is into, this is plus. That is simply OR gate only. In previous AAPMT it came 2 times. I will give some of the Boolean expressions, you can work on that later. Right, which Boolean expression is not correct? Which Boolean expression is not correct? Your options are A bar dot B bar is A bar dot B bar whole bar is equals to A plus B. Second option, A bar plus B bar whole bar is equals to A dot B. Then A dot B whole bar is equals to AB. And then 1 bar plus 1 bar is equals to 1. Chikku makkulu andre chikku makkulu problem. What is the correct answer? What question I asked? Not correct. Excitement people. Not correct. Fourth option is not correct. See that these two are what? These two are what? De Morgan laws, right? Those are correct only, of course. We cannot say that De Morgan is wrong. So that is of course correct only. So this is A dot B whole bar. What happens here? Bar gets cancelled. What is the answer? This one is wrong answer. This is how much actually? 0. Chikkumakkalu problem. Then next one. To get the output 1, the input A, B, C should be. The input A, B, C should be. Your options 101. Write the options 101, 100, 110, 101, 100, 110, 010. మా కరోనా తల్లి you have to sneeze like Sarah to not disturb anybody. Correct, Sarah? Kichik antara. Which is the correct one? What should be the outputs to get the maximum output? That is what the question. See, you can either check the trial and error method. That is the best method actually, but it will take little time. Otherwise, you can solve the Boolean expression. Anything is correct only. So here this is which gate, of course? OR gate, right? OR gate nothing but A plus B. Then C is going here. So again which gate there? AND gate. AND gate nothing but what will get here? A plus B into C. That is the final Boolean expression. After that you check the options. First option is what? 101. So that 1 plus 0 into 1. So what is the answer here? 1 plus 0 is 1. 1 into 1 is 1. Yes, we got the correct answer there only. If they have not given in the first option, then again check the second option. What is the second option given? 100. 1 0 into 0. What is the answer here? 0. In the same way you can check the other options also. Otherwise, if you don't want to find the Boolean expression, directly substitute the values here. 101. 1 plus 0 is how much? 1. And then 1. And then 1 and 1, how much output? 1 only. You can check any other ways. Then next one. The combination of gates shown will produce. The combination of gates shown will produce. The combination of gates shown will produce. See that guy, he is saying something. See that problem first. Number 1 easy problem. You cannot say to physics like that, Ray. Yeneno? Options options are and, NAND, NOR, XOR. XOR, is that correct? Yes. So there is no doubt that already yesterday we have solved, I think, but little different way we have solved. Now this is A and then this will be how much here? A bar. How much is going from here? B. B ray. From here how much is coming? A. This one is how much is coming? B bar. Then what I can write this one as? A bar B. This is A B bar. So what I can write finally? A bar B plus B A bar. B bar A. He'll beat me or what? So this is what? Which symbol this is? XOR. Those are the options. And, NAND, NOR, XOR. Then next. There are problems. Yes, next one. The truth table for the following combination of gates is. The truth table for the following combination of gates is. I am writing now, you also have to write. Just by seeing the options, don't tell me the answer. I am doing this much of hard work. Uday, I will check your notes. Check ಮಾಡಿದ್ವು ಅಂದರೆ ಕೂಡ ನಾನು ಮಾಡಲ್ಲ ಅಂತಾರೆ ಅವರು. Shall I stop them? Yeah. Among these two options is which one is correct? First option is correct? Yes. Check that. 0, 0. 0, 0 is how much? 0 andre which gate I did not say even this is 0. I have take. Otherwise you can check by the Boolean expression also, no? So what will get here? A, B. Then here how much will get? A. So that A and then A plus AB. Then A common, 1 plus B. 1 plus anybody. Answer is A. Okay. A is 0011. Y also 0011. Here A is 0011, but Y is 00011. Wrong answer. Clear? So that is how you can check by the Boolean expression, or you can sit for 1 hour and then you can check each and every case. See, 0, 0, okay, 0, ಮತ್ತೆ 0 ಹೋಗುತ್ತೆ ಮತ್ತೆ ಏನು ಬರುತ್ತೆ ಅದೆಲ್ಲ ಮಾಡ್ಬೋದು, ಬಟ್ ಬಯಾಲಜಿ ಮಾಡಬಾರ್ದು ಆ ಟೈಮಲ್ಲಿ. Right, next problem. Previous APMT question. In the following figure shown, and logic gate circuit with two inputs A and B, with two inputs A and B, with two inputs A and B, and output is C, The voltage waveform of C will be. The voltage waveform of C will be. Tell me which is correct. Which option is correct? First option, third option. Third option. Who said third option? First option is correct. Most of the problems, first option only will be correct. Madam, ಆ ಥರ ಹೇಳಿದ್ರೆ ಮತ್ತೆ ವೀಕೆಂಡ್ ಎಕ್ಸಾಮಲ್ಲಿ ಫಸ್ಟ್ ಆಪ್ಷನ್ಸ್ ಇಡಬಾರ್ದು. Okay, this is AND gate, no, they said. AND gate 0 0 0 1 1 1. So that here 0 0 my answer should be 0, 1 1 means answer should be 1, 0 1 answer should be how much? AND gate 0 1 0 0. This should be output waveform. Nothing but 0 1 0 0. So that 0 1 0 0. If you take this one 1 0 1 1, that's wrong. Then this is 0 1 0 0, this is 1 0 1 1, this one is how much, tell me? 0 0 0 1. This one is 1 1 0 1, last one is there still, so that is 1 1 0 1. So which is the correct answer here? First option is the correct one. So that's enough about the logic gates. We have done already PhD in that. Next we will see the transistor. Still transistor is remaining. Transistor, ever discussing about transistor output input graphs finished? Output and then input graphs of the transistor finished? Saturation region, active region, yes. In active region what happens? Transistor will act like what? I said one table. I said one table, no? In active region what happens? Forward bias and then reverse bias. Okay, biasing only I said. In bracket also I said, no? Saturation region I said, yes, amplifier, inverse saturation was there, and then cutoff region, switch off on, off, and then active region, switch is on. So that is what we have discussed about the biasing of the transistors, and then after that configurations we have discussed. Common emitter. In that configuration we have seen the output and then input graphs of the whatever the transistor we got, and then in that which characteristics is important? Output characteristics. In that saturation region will be there, cutoff region will be there, and then what is that? Active region will be there. In the saturation region I said that the current is independent of the input current. We have seen the output and then input characteristics. In that we have drawn the voltage and then current graph for the input. For the input, whenever you see the transistor rough diagram, I will draw common emitter configuration. This is the base, this is the collector. So for the input characteristics, so here current is how much? Of course IB. Here current is how much? IC. Current is IC there. Here current is how much? IE, of course. Here voltage is which voltage here? VBE. Here voltage is VCE. Whenever you are drawing the output graph, then what you have to input graph, at that time what you have to take? The graph between what here? Input current and then input voltage. What you have to keep constant? VCE you have to keep constant. Output voltage you have to keep constant. Here VCE is constant. Then we got even the resistance also. Ri is equals to, do you remember that? Ri is equals to, resistance equals to, what is the formula? V is equals to IR, R is equals to V by I. So that which voltage we are talking about here? VBE, input voltage, and then input current is how much? IB. delta will come whenever we have taken the AC signal, only VB and then IB will come whenever we have taken the DC signal. There is no much difference in that. Of course, which is constant here? VC is constant. Then whenever we are discussing about the output, at that time R output, R naught is equal to, what is the formula we got? Delta VC by delta IC into, which is constant here? IB was constant. Not into, that is IB was constant here. So we have keep the base current as constant and then we have drawn the output characteristics. In that we got the graph between the VCE and then IC. In the saturation region we got the graph like this. You remember that? Yes, like that it was there. Now this region I said it has a saturation region. This is the active region. This is which region? Cutoff region. In the saturation region I said that IC is not depending on the IB. IC is independent of IB. Whatever the value might be changing, this is of course here IB1, IB2, IB3 like that we got. Whatever the IB value might be here, nothing is coming in this. So that in that saturation region, this is the saturation region, in that I said that IC is independent of IB. Then in the active region, what we got? We got the maximum voltage there, maximum current. At that time the transistor will work like a on switch. Then in the cutoff region if you see, of course IB is very small here, IB is very small, then IC is approximately how much? 0. There is no current flow, so that the switch will be which switch? Off switch. Now I am discussing about the transistor as a switch. In this concept only I am mixing it. So in the output graph we have got that saturation region and then active region and then cutoff region. Active region we are getting the maximum current flow. Maximum current flow nothing but switch will be on. Here minimum current flow, there is no current flow only. Of course it is approximately 0. Then what we can say here? Switch is off. Now here transistor as a switch means, what we will do means we will take a biasing of the transistor here. So this IB nothing but the base will be connected to the forward biased, and then here collector emitter region will be reverse biased. What is the difference between this battery and that battery? This one is high voltage, okay, this one is normal, okay, up to 0 to 12. This one is up to 0 to 12 volts and then this one is more than 12 volts. Okay, so VC should be high voltage and that should be in which biasing? Reverse biasing. See that we have, whenever we have taken the, which configuration? This is CE configuration. Current is coming out. Current is coming out nothing but which transistor? PNP na NPN? Current is coming out. Remember the symbol. Current is coming out. Emitter is giving nothing but that is NPN. Why? Because at the emitter we are having the maximum charges here. Maximum charges will be there in which transistor? Nothing but NPN. So that this is NPN transistor. NPN transistor. Now this is will be taken like this. NPN nothing but this is a base, this is emitter, this is collector. Now base emitter region is which configuration? This is NP nothing but which configuration? Which one? This is which configuration? Which biasing I am saying about? NP. For the base we are giving the N and then for the emitter we are giving the P nothing but this should be in which biasing? Nothing but reverse biasing. And then emitter collector region should be in which biasing here? Forward biasing. Of course it might be forward or reverse, but base emitter junction is in the NP configuration and then emitter collector junction is in the forward biasing, otherwise PN configuration. So you just forget about the biasing. The biasing will be different for the different applications. For the amplifier it will be different, for the switch it will be different, for the oscillator it will be different. Transistor will be used as an amplifier, I said already. Transistor will be used as a switch, on or off switch. Already we have seen the regions here. In that region saturation and then active and then cutoff region. And also the transistor will be work like an oscillator. Oscillator nothing but what oscillator will do? It will generate the waveforms. Without any battery, oscillator will do that without any waveform. I am not giving any input current, otherwise any input voltage, but what happens means it will generate the waveform. How it is possible? Nothing but I will take the LC circuit. You remember the LC circuit, combination of LC circuit? In LC circuit what happens? First of all, what will take capacitor is fully charged. After that we will connect the inductor. Then what happens? The charge get discharged. Then again charged, again discharged. So that what we can form there? Waveform we can form. So that by that only we will form the transistor as a wave, oscillator we can discuss. So first and foremost is transistor as a switch. For this switch, what should happen? Nothing but the base emitter junction should be in the forward biasing and the emitter collector junction should be in the reverse biasing. This is a requirement, then only it will work, otherwise it will not work. Okay. Now base emitter is which configuration generally? NP configuration. So NP configuration I have to give in forward biasing, nothing but what I have to do? For B what I have to connect? For B is what here? N nothing but which terminal I have to connect? N negative terminal, right? So negative. For the emitter what you have to connect? Positive. Otherwise can I say higher and then lower? Here emitter is grounded. Emitter is grounded. Nothing but emitter is voltage is lesser, otherwise base voltage is lesser. Grounded nothing but how much this is? 0. 0 nothing but is it in forward biasing now? Check or not? It is forward biasing or not? Check. This base emitter should be in the forward biasing, I said. Is this in forward bias or not? You just check once. See that whenever I set the PN junction diode here, at that time I should make it as a forward bias, nothing but for the P what should be there? Positive terminal of the battery. For N, negative terminal of the battery should be there. Now here I said emitter is there as P and then base is there as N. Nothing but to make it as forward bias, I have to connect what? Base for the lower potential and then emitter for the higher potential. So this is emitter is connected to already what here? 0. So emitter should be 0. Emitter is 0, nothing but it should be lower actually. It should be lower here. Is that correct? Lower or higher? Higher. It should be higher actually. Emitter is positive, nothing but here emitter should be higher and then base should be in the lower potential, so that you have to take in this direction. Clear? Next one is emitter collector junction should be in which biasing? I said reverse biasing. Reverse biasing nothing but collector is lower potential and then emitter is a higher potential should be there. So that emitter is at higher potential, this one is emitter is higher potential and then collector is at the lower potential. So now I can say that here base emitter junction is in the forward biasing and then collector emitter junction is in the reverse biasing. Now here the one more thing is you have to mainly understand about the PN junction only. Whenever I have given low input voltage, Vi is low, then what happens? What happens to the junction diode? Tell me, only this junction diode, what happens to that? Low voltage I have given. Low voltage means, can I say that current is, how much current will flow? Low current or high current? Low current only. Low current nothing but resistance is? Higher resistance, right? Then after that, here voltage Vi is low. Now you just think about the depletion layer. Whenever I have given the lower potential and then that to which biasing I said here? Forward biasing. Forward biasing what happens? Depletion layer width will decreases. And also whenever the depletion layer width will decreases, then barrier potential also what happens? Decreases only. So depletion layer width is decreasing and also in the forward bias, higher current or lower current? Higher current. Forward bias nothing but higher current. So that I am applying the low voltage here. By applying the low voltage, what I am doing nothing but I am keeping this in which biasing here? Forward biasing. Forward biasing nothing but I can say that the depletion layer width will decreases and the current flow will increases. So here we are taking the low voltage, we are getting the current as what? High. But what you said? Whenever you said that voltage is low, nothing but current also low you said, but that's wrong. Why? Because this is in which biasing here? Forward biasing. In forward biasing, depletion layer width will decreases and the current flow will increases. Current flow is increasing nothing but, can I say that resistance is less? Current is high nothing but resistance is less here. Clear? Now at that time, whenever this one is having the higher current, then what happens? Nothing but for the collector there will be lower current. Why? Because whatever from the base we are getting, that current is entirely here getting grounded only. For this very less current is going. At that time the switch will be off. I am giving the lower voltage here. At that time the switch will be off. Why? Because here what happening? Here higher current, nothing but here current will be lower and the resistance will be higher. Resistance is higher, nothing but more current flow, less current flow, less current flow. So that the switch will be off at that case. Then whenever I have taken, this one is Vi is higher, listen properly, Vi is higher. Which biasing? Of course, forward biasing. In forward biasing, I am giving the more voltage. At that time what happens? What happens? Barrier, nothing but I am crossing the barrier potential. At that time what happens? I think you have to revise that PN junction concept once. PN junction concept you have to revise once. You are getting confused by that. Okay na? Take time. There is no problem. 5 minutes you can revise that and then you can we can discuss after that. PN junction, depletion layer concept you just revise. Mechanism of PN junction. Good morning. Idu madilla? Otherwise we will continue in the individual classes otherwise. Yes? Meanwhile you just revise everything. What I said nothing but PN junction of that.